Imagine an engineer standing next to a newly constructed bridge. He looks over his calculations, shakes your hand, and tells you that based on historical averages and complex simulations, the structure will probably hold your weight. You wouldn't step foot on it. When we build physical infrastructure, we demand absolute certainty. We rely on the strict, unbreakable laws of physics and mechanics, not statistical likelihoods. Yet in the digital world, we are actively handing control of our most sensitive, high-stakes operations over to deep learning algorithms that operate entirely on probability and pattern guessing. We are running the infrastructure of certainty using the mathematics of guessing. Look at the sectors where this mismatch is playing out, starting with raw earth materials extraction. We see it in the physical logistics of heavy resource management and timber processing, and we see it in the high-voltage power grids that keep entire nations functioning. This slide breaks down the inherent flaw of standard AI. Deep learning operates in continuous mathematical space, optimizing for averages. As noted in opacidad estructural and fragilidad de distribución, these models are opaque and fail unpredictably on the margins. A 95% accuracy rate sounds like a massive success in a boardroom presentation, but when you deploy that model across millions of automated operational decisions, a 5% margin of error generates thousands of incorrect, indefensible failures. Placing an opaque model at the center of critical infrastructure creates a permanent risk, a blind spot that leaves both legal and financial teams without a way to audit the damage when a failure occurs. To solve this, Juan Carlos Lopez and the team at Micromind AI developed a strictly deterministic alternative to the deep learning black box, known as white box AI. This contrasts the two methods. On the left is the chaotic guessing of continuous mathematics. To build white box AI, we use the rigid Boolean hypercube on the right. The exactor engine searches for exact laws, creating output that is 100% auditable. Because the architecture relies on strict logic rather than statistical curves, the system achieves zero interpretability cost by design. Every decision explains itself. This graphic illustrates the first step of symbolic machine learning, adaptive binarization. The system takes the continuous noise of operational data and slices it into strict, discrete boundaries of ones and zeros. With the data cleanly separated, the exactor engine begins an exhaustive Boolean rule synthesis, searching the discrete variables using pure logical operators. This blueprint maps out the internal architecture. The engine drives the data through strict logic gates, specifically AND, OR, XOR, and NOT, forging unbreakable deterministic rules. Looking at this bell curve diagram, the result is clear. The process ignores statistical noise and dead zones entirely, isolating what we call islas de certeza intermedias, segments of data where precision is absolute and false positives do not exist. The AI has stopped predicting what might happen. It maps exactly what is happening and why, expressing it in clear, human-readable text. The European Union Artificial Intelligence Act, along with incoming global regulations, now mandates strict liability and total transparency for automated systems. Corporations now face a choice between renting unexplainable, opaque algorithmic expenses from third-party vendors or owning the exact logic governing their decisions. This 3D blueprint introduces Propiedad Intelectual Operativa, or PIO. These logical rules meet the International Financial Reporting Standards for intangible assets, meaning they can be documented and registered as property. This shift allows legal teams and auditors to verify every automated decision instantly. Because these rules are identified, controlled, and linked to revenue, they qualify as a formal corporate asset. By codified operational knowledge into PIO, a company converts a vague technical expense into a recorded, auditable asset on the balance sheet. This benchmark graphic provides the empirical proof. Tested against complex, independent databases, the algorithm discovered 185 distinct Boolean segments, achieving 100% precision with zero false positives. The research is complete. The algorithm is scientifically verified, fully built, and ready for deployment. We invite the Applica to Idea program to partner with Micromind AI, validate this engine, and embed transparent, deterministic logic deep inside our national critical infrastructure. Moving from probability to Boolean logic allows us to manage digital decision-making with the same rigorous engineering standards we use to build our physical world.